So, hello everyone. Uh, Welcome to this instructional video on how to model and detail walls in IMPACT Precast. And we were just waiting a little bit for a few of the attendees to join, but maybe we can start. Okay, just a little bit about myself. I'm Hemant Bhaskar. I'm an IMPACT support engineer here at StruEngineers, and I have 3 years of experience in precast domain and impact technical support. So the agenda for today will be the types of walls and definitions in impact precast, the automatic lifting and bracing placements that we have, reinforcement templates for walls in detail. We will see how to create the reinforcement templates and also how to apply them. Then also we will be creating shop drawings and see it contains how to adjust viewports, its views, and in general how to plot them. So yeah, we can get started. So this is our empty project manager. So this is our empty project manager, and we'll start from the floor plan. Let me open that up. I'm sorry because I didn't keep it open beforehand. It will just take a minute. So in our model we can see we don't have anything currently, and I do not think we have any templates either. Yeah, we have one, but yeah, we'll look into that after we get started. Okay, so we are in our main view for the AutoCAD, and this is a floor plan. And for drawing walls, we'll first start by defining how we want those walls to be. So we'll go into the wall definitions. So currently I do not have anything on our project level, so I will okay, I actually have one, but I will just delete it. We'll start with the sandwich walls. I will create a new definition. It will be, because I am using 340 mm thickness, I will be using that. So inside our definition we can define our inner panel thickness with insulation width and the outer panel thickness. So we'll start with 120, 150 and 70. So we have to total 340. Now we'll choose the material for our panels. So I will choose concrete for inner and outer panel, and for the insulation I will be using polystyrene. Now the reinforcement layout, we will see how to create it, but for now I am just assigning a 24 RC, and we will be using it to represent on the normal scale. So it is the production setting how we want to plot this cast this wall. Do we want inner panel up or down in the casting mold? And then we look into the lift and bracings. So now here we have the definitions for the minimum distance for 2 lifts points, so that many of the times we have the necessary to put 2 or maybe 4 lifters in our wall according to the length of the wall. So we'll just define 2000. So below 2000 we can specify if we want to use even less or maybe the single lifter. And for the maximum distance we'll be using 4500. So if our total total length of the wall goes above 4500, we'll be using 4 lifts. Now minimum spacing for the 4 lifts, if we are using 4 lifts, how much distance between 2 lifts should be? So I'm just putting it about 1000, and okay, we'll add just some of the lifts in here. So now we can add the sequential lifts, because according to the mass, most of the times this happens that we need the different lifts for maybe it is 5 or 6 tons. After that, maybe for the 9 tons we require different lift, and for maybe 10 or 12 tons we require different lifts. So according to our capacity, we can define different lifts for our walls. So I'll just add 3 of them. Okay, so type should be maybe 60. Type can be anything. You can specify different types so that you can use different different lifters configuration for different walls. So I will just add 3 types to be 60 here, and the names of the custom material that I will be using is 160. It will be maximum 7 tons. I will use 0161 and which have maximum capacity for maybe 9 tons, and for 0162 this custom material will be max good till 12 tons. Now we have the setting for the okay, so we just define only the 2 lift points, and we can define 1 lift point also. If our length of the wall is less than 2000, we can add the single lift also. So again, for the same type of the lifting, and the name should be, I think I will use only 160, and the max the support for this lift will be maybe 5 tons. Okay, now we have 1 lift, 2 lifts, and for the 4 lifts again we'll use the same settings. It will be 60, 60, 60. We'll add the same custom material for this and 0162 for the last one. And again we already saw that for 160 is good for till 7, but now we are using 4 lifters. We can maybe add the increase our capacity until 15 tons. Okay, now whenever our length of the wall is beyond 4500, we will be using 4 points automatically, and whenever it is less than 2000, we will be using the single lift point. Now we also have this option here, default lift type on the other. So many of the times we need the lifters on the other sides of the wall for taking it out of the cast, or maybe just for the erections, and we can also define that here. So for the default types, our will be 60 because we defined that type as 60. On which side of the wall should we add the extra lift? So it will be on the left side, and again we can add the rotations of the lifts as well. So for the bracings, bracings are used for holding walls in the place when it is erected, and or maybe some of the work around it is to be done. And we have 3 or more configuration. We have 2 configuration how to place it. We have the fixed distance or maybe the part of the height. Okay, so either we can either choose h by y. H by y will be, h is our total height of the wall, and y in how much distance it should be from the bottom of the wall. So if we want to place our lifter at 1/4, it should be 4 here. So basically inverse of at what distance we need to place for the height. And for the we can similarly choose the fixed distance, and for the fixed distance I can add maybe 1500, so it will be placed at 1500 from either end. Distance from the long side, again we can either choose the center of gravity, so that program will put the bracing according to center of gravity of the wall. Otherwise we can use the fixed distance or the part of the distance. Again, for this I will use maybe 4 times. Okay, now we have the naming tab. In our we can define where our walls this particular wall fits to be. So it is a sandwich wall, so I will just give a designation SW. And for the prefix designation is this is for the element type and the element mark. So whenever we make a new wall, for this definition we'll be getting SW as suffix automatically, and SW34 because it is the SW34 definitions. And for the drawing we can either choose the different drawing name, or we can just choose the SW also. So I will be using 34 dash, so that we have the width of the wall in the drawing name itself. And the drawing type will be sandwich walls, and the drawing template SW layout. Now this template is currently present in our standard, and we are using that. Okay, so this was for the sandwich walls, and we'll just create 2 or maybe 3 walls according to our distances. So I will just create one of the walls from here till here, and I will add one of the larger walls so that we can look at our 4 lifter configuration also. Let me check if the definitions are correct. I think we use the different definitions, that's why it is. Okay. To edit, I will check our lifters. We have a reconfiguration here. Okay. Let me just draw this again. So I will just create a select sandwich walls. I will again take the starting point. I will choose the properties to see if we have this correct definition. Yes. I'll add one small wall for the single lift, one middle wall for the 2 lifts, and one of the larger walls for the 4 lift configuration. Okay, now as you can see, as we are going about now this particular length is lesser than 2000, so we only have the 1 lift that we defined, and this one is in between 2000 to 4500, so we have 2 lifts and 2 bracings, and for here we have the 4 lifts, and if we measure, the distance between 2 lifts will be 1000 that we define in the definitions. And for the horizontal we chose the 1/4 of the total length. So if I just take this, it is 5600 approximately, and the half of it will be nearly 1300. So yeah, actually it should be 1400. Yeah, it is correct. And then for the vertical distance, maybe we can wager that too. We set up the to be 1500. Now 1500 is from the top, I guess. Yeah, from the top. I will just measure it once more here. No, actually it is from the bottom. Yeah, 1500 from the bottom. So now these are our sandwich walls for this configuration, and similarly we can define our solid and insulation walls. So in our wall definition, wall will be only the solid wall. We'll go in here and I'll add a W20. So for W20, the thickness will be 200. Inner panel material will be concrete, and the template, again I have defined one of the, this is from the beginning, so I have added that, and will be represented in the normal scale. Again we have this cast production tab. If we want to cast this according to battery or from the plan, the battery will be basically, the wall will be casted from the top, means it will be erect while casting. And in our lift and definition, will again, it will be again the same procedure for this also. So we'll quickly add some of the values here. Maybe 800 will be sufficient for these walls, and we'll add 3 new configurations. Again we can use the similar casting material, or we can use the different casting material. So here I'll be using again same one, sorry, the type, it should be here. The different types, how that work, I will just show you quickly in a minute. And 0162, again it will be good for 7 tons, 9 tons and 12 tons. Now what type does is, actually we can add multiple lift types, but we can maybe give it some different name, maybe 45. And for the similar, or maybe for different configurations, for the weight we'll be using different lifts. So you can choose while editing if we want to continue with the similar configuration, or for one of the particular, if one of the particular walls require different configuration, we can use that as well. So in here I will add the bracings. Again, fixed distance should be 1000, and I will just use the center of gravity for this one. Now naming, I will add the W, and it is a 200 mm thick, so I will add just 20 dash, and I will add our type, and it will be template. Okay, so we don't have default template yet for this one, so we'll add that soon. So similarly we can draw the other two as well. We just saw the solid walls, we'll just go into the insulation walls and define that one as well. So I will give it IW maybe 27 for 270 mm thickness. So for the inner panel and outer panel insulation thickness, we'll add maybe 120 and 170. And for the inner panel, again we are going to be casting concrete, and the insulation will be using polystyrene. Template will be, again I have one of the template reinforcement template setup, and layout will be in a normal size. Okay, everything looks good, and we will add similar configuration here. It will be maybe 800, and again I will add we'll add similar type for this one as well. Again we can use the different custom material, but we will be using the similar one here also. And again the mass will be 7 ton, 9 ton and 12 ton. Okay, and again similarly we'll define this by center of gravity. Okay, for walls I think we didn't define the default, yeah, lifting type. Default lifting isn't added, we'll just define that here. In insulation wall, let's check that as well. 60 and 60. Naming convention, yeah, we actually didn't add it here, just add it. And for the drawing designation, it will be 27 dash. Then again the insulated wall for the drawing type, and we do have one of the template available. Okay, so we have defined our walls here right now, and for our lifts we have added for all of the three definitions, and we'll now look at the next part, that is the reinforcement template. Before we begin drawing any shop drawings, we should define it beforehand. So in here I already have one of the template. I will just edit it and show you how we can configure. So we have different types on how to add the mesh or the bars around in the wall. So we have the double bar mesh and double rebar. The bar mesh will be the loose bars that will be added as mesh. Then we have double mesh, double rebar, then we have single bar mesh, and various types in here. It will be according to your requirement that we can add different configuration. So here I am choosing double mesh, double rebar. For a horizontal mesh inner panel, as you can see, we are pushing both facing back, that is the inside edge here. We can change that if we want to place on the other side mesh, or we can maybe choose the mesh on the inner side or maybe outer side. These small dots are the mesh that we are seeing here. Now in here we have the configuration for the outer mesh as well, and then M1, M2 will be the placing distances for the mesh and the rebars. So as you can see, M1 and M3 is the mesh distance that we can add. So from the face of the panel it will be added from the 25 mm, and for the M2 and M4 it is the placing of these rebars. So I will add maybe that at the 35 mm from the face. Then we have the cover for the TB1 and TB2. Here you can see we have the cut and placement, two different configuration. The cut will be how much this vertical bar, how far from this face will be cut. So it will be cut from 25 mm from this edge. And for the placement of this particular black bar, as you can see, we'll be placing it at 35 mm. So it will be this black bar will be placed at the 35 mm. So we added that, and we are rounding up the straight bar length to the 5 mm. Now we have the configuration for the edge reinforcement. So edge reinforcement is basically every time we create a new wall with this RC configuration, we will have this reinforcement bars automatically put in the walls. So here we have the quality and the top dimensions. So here we can choose from the different qualities that are available. The quality will be just the designation or the steel quality that you use in the factory. So for the top dimension, I'm using the 6 mm. We can of course change it to maybe 8 mm or maybe 10 mm also. Again, the top quantity only for 2 for the inner panel, and outer panel will be using only 1. We can change it to maybe 3 or 4 rebars as well, but we'll keep it 2 as per the standard it is. Similarly, we can change left side, right side dimension, rebar dimensions, and bottom side also. Now we do have option to add maybe a straight bar or maybe a C bar at these two edge, left and right. So currently, as you can see, if we choose the C bars, we can add the distances, that how much anchorage we need to add. So I will add maybe 250 anchorage. Yeah. And this end cap reinforcement, so whenever we add the end cap to our walls, we'll be having if we do have the reinforcement in that particular end cap, it will be placed according to these distances that are presented: 30 to 50 to 70 and to 70 for the different edges of the wall. Then again, we have this configuration for the opening. So anytime we have any opening in our wall, we'll be placing maybe 2 bars around it for the top dimensions. We'll be placing 2 bars for the bottom side. We'll be placing 2 bars in the inner panels for the left and right side, and similarly only 1 rebar for the outer panel, which is thinner than the inner panel. And then again, we can add the diagonal length as well. As you can see, we have the diagonal length. Some of the clients do require this, so we can add that here also. If we don't require it, we can just keep it empty. We can keep it to 0. Now for this, okay. And then we have the measure type. Now here we can choose how long this reinforcement around the opening should be. Now here we can say anchorage plus height. So for the horizontal length, we are using the anchorage that is 400 beyond the opening, and we are going the full height of the wall for the length of the vertical bars. Then we can choose anchorage length for both of these types, maybe 400 mm for the either side from the opening for the vertical and horizontal. Then we have the element size. Again, this will be used for both of the sides, means horizontal and vertical, will be going till the length of our wall. And then we have the user defined. So here we can choose how long this bar should be. We can give in the definite value, and it will be placed centrally so that we will have the symmetry around the opening. So here we'll be using maybe anchorage length for the 400 mm. Now if we do have any opening for the end cap, for the openings, we can define the similarly for the edge reinforcement. We can define our spacing for these tips as well. So even in the next tab, we have the mesh. In the mesh mark, we have this by default in our standard, but of course we can add the new ones if we like. If we don't need a mesh for this particular one, we can keep it to none, but I'm adding this one by here. Then the wall beam and wall column, these are two elements where if it will be added as a reinforcement group. So whenever our opening is too close to the edge of the wall and the thickness is very less, in that particular case we do need to add extra reinforcement, so we'll be adding that from here. So now for this reinforcement wall beam, so here we have the shape code for the stirrup, that is N, and as you can see here, maybe if I change we can get the reference shape codes as well. So by default we usually use this round stirrup, so that is okay. And this is the spacing 200 mm. So in this reinforcement group the stirrups will be placed at 200 mm center to center. Then we have the quality, again it completely depends on the factory, and we have TBA and TBA, so it is basically the cover for either side of our reinforcement groups. Now for this straight reinforcement, that is these bars we have available here, we can define how much bars should be placed, and it will automatically multiply by 2, because we do need to place the pairs by default, so we will be it will be multiplied by 2. So I will just keep it maybe 4 for this. Then in the wall column we have the similar settings, and yeah, that is about it for the reinforcement. Now this 24 RC for the sandwich, actually it should be 34 RC because we have the wall thickness as 34. Creating the new template will be the similar experience. We'll just adding our configuration, we'll add our values according to our need, and then okay, it should be 5. Okay, minimum 5 rounding is required. Then edge reinforcement, again we can add our values here, and it will be similar configuration as this one before. Okay, then we will close our reinforcement template, and if I just edit one of these walls, so here actually I have chose that particular reinforcement template, and it will be shown as the normal layout. So by default actually in our definition it was 24 RC, but we just changed the name, so we had to select again. Okay, and now we will save this wall and we'll create a shop drawing. So we give the designation SW1, so it by default took the SW1 as the prefix, and when we create the shop token for this one SW1, the drawing name will be SW34-1 because we give the prefix for drawings 34- in our definitions. So I'll just start preparing a drawing. It will take maybe a minute or two. So after this, if possible, we will also look into the MEP keys. So we do have reinforcement. Yeah. Okay, so we are in our model. In here we have our 4 lifts. Everything is dimensioned by the program, so we don't have to do that, and all the thicknesses are added, and the bracing is also placed here. So in here we only have to have the custom material, and for the reinforcement template we'll just click this to draw our RC template. Okay, let me check. Okay, it is still 24 RC. Okay, I'll just redraw all of this. Okay, so as you can see in our reinforcement view, we have all of the bars that we added. As you saw in here, we added the C bars for the sides, and it is added here, and the 2 of the quantity of this bar is added. Now we have added the 10 mm diameter bar, so it is also indicated. Then if we look at the straight bars, now we have the 2 straight bars of the dimension 8. The length is also added here, and we have the similar for the left bottom side. Now for the outer panel we have the similar configuration, but everything is a one quantity because we only added one. And our mesh is also added here. Now here, as you can see, the annotation is 1+1 because we need to add 2 mesh for this inner panel. If we look at our section, we can see that we have placed this mesh, and this is placed at I'm guessing maybe about 25 mm because that was we choose here. And for the reinforcement bars we have the 35. Okay, maybe just placed a little bit here further because to avoid clashing. And if we check here, our reinforcement should be, yeah, it moved it down because to avoid the reinforcement clash. And similar 25 mm cover is added on the other side as well. So that is most of our reinforcement template. But as we saw earlier, we also defined our end cap reinforcement sizes. Now this particular wall doesn't have any end caps, so if we add that end caps, we'll just configure our end caps from here. So I have some of the end caps made before, and I'll just click OK. So again our drawing will be, our panel will be redrawn. I will just click yes to everything, updating the lifts and bracings. Okay, and just once more we'll be clicking our create the reinforcement proposal. So as earlier we defined in our reinforcement template that we had, let me just show you quickly. In here, if we check our reinforcement, we added the 300 spacing for the top, 250 for the bottom, and 270 for the other tools. So if we check here, we have this bar added at the 250 spacings. We have this particular bar added 270 spacing on the other side, and for the top we have this bar added as the 300 mm. Now these bars have been defined in our cast end caps beforehand. If we check our end caps in here, I'll just go into the definitions, and in reinforcement we have added this reinforcement. Now how to add this reinforcement in our end caps, we have seen it in our earlier version, earlier presentation. So what this is, which are available on the YouTube, and all of these bars that we added by the template, which is added by our program, are listed in here. As you can see, we have all of the bar marks, and the lengths which doesn't have the bar marks, these are listed by the lengths, and our mesh is also listed in our reinforcement schedule. So this is the reinforcement template, so we can add it pretty quickly. But also we added some of the reinforcement for openings as well. So currently this doesn't have any opening, so it is skipped. So we can maybe add one of the openings for this wall. I'll just quickly check if we have any of the, yeah, okay, so we have this window here we can add with our end caps defined in it. So I will just add a draw opening. I will choose our opening, that was F3, and the thickness will be 340 for this wall element, and I will add it around here. So if I just MTO all is basically material takeoff all, so that any changes that we made in the drawing will be communicated to the database, and also accordingly new changes will be made in the views. So still we don't have our reinforcement around the opening, so for that we'll just create our proposal again. So now we have all of these reinforcement drawing here. So there is some of the cluster here, maybe we have to clean up a little bit, but basically as you can see we have added the extra bars and the end cap bars that was present in the end cap which are used for our opening is also added. If we just remove that, it will be much clear, I guess. We'll just edit our opening, and here I'll choose none. Okay, and we'll just again take everything, material take off. And again we'll run our RC template proposal. Okay, so without the extra end cap bar, so as we can see, we have the clear picture how we added the verticals and horizontal rebars around this. Again, the two quantities are added for this one. Maybe you can take it down from here. So the 2 plus 2 quantities have been added for this particular panel, and the single is added for the outer panel. Now similarly, we can define another templates as well for our solid walls and insulation walls. I will just quickly show the overview because we are running a bit out of time. So in here for the solid wall, we have the similar configuration. We can define according to our need. How do we want to place this? Then again, I'm choosing the default one. We have these covers and how much what place the bar should be placed, and the round bar, how much length we need to be rounded off to. Again, the similar configuration is here for the opening, edge wall, mesh, wall beam, and wall column. Okay, so we didn't see actually the wall column, so maybe we can look at it in here. So if I just move this opening to the right where it is very close to the edge of our wall, and I will just again empty once more so that everything is updated in the database when we add those particular beams. So I will choose this draw reinforcement beam. So already we have defined our stirrups and all of these distances that we need. So I'll choose the bottom edge here. I'll choose the for it will be added for the inner panel. I'll choose the top edge and the extension of the line. So I will add the beam from maybe here till here, and the length of the bars, again we can choose by the element length, or maybe we can define it also. So I'll choose by username. So the first again will be here to here, and where we want to place the distribution bar. So maybe for here for the stirrups, I want the distribution bars to be there. Now all of the configuration that we had before is added. As you can see, A and B also calculated from here according to the width of that column, and the bending radius is also calculated. So we chose the 4, so that's why we have the 4 into 2 quantity here. If I just click OK. Okay, now it is a bit close together because I think we have the end caps which is obstructing our view. Maybe we can just okay, we will just add the column so that we'll have the better. We added the little bit too much reinforcement in the column, I guess. So for the column side, we'll choose the similar thing. We'll choose the inner side, then we will be adding it to the inner panel. We'll choose the edge of the wall, again the extension from maybe here till here, and we'll choose our length of the straight bars from here till here, and the distribution line will be placed around here. So for this one I will be choosing lesser bars. So yeah, so it is a much better view. And if we just expand this distribution line, you can see we have added these extra stirrups in here. And if we just do the material takeoff for our reinforcement, and we will draw our 3D solid with the reinforcement and custom material, so that we can see in 3D how those reinforcement have been placed. Okay, so we have lots of reinforcement for the bars, I guess, so that's why it is so crowded. But here we can see our extra reinforcement group have been added here also. This particular reinforcement group that we added as a stirrup, as a column for the opening. So this is it for the reinforcement template, and for the next one we can look at maybe the MEP key. Let me quickly check, did we cover all of the topics? So we did cover our automatic lifting and bracing placements, we covered the reinforcement templates, and now the creating shop drawing. So okay, so in here we took the shop drawing, the template layout that was already placed in our standard. So we'll already have a basic template, but if we look into the layout, so for some reason if I need to place this end caps at the bottom of our template rather than on the side, I can just do it from the base. I will go into our viewports. I will delete these three of those because I need to adjust the section, this solid portion, and also the end cap view. So I will be clearing those three: end caps, section, and then the solid view. Just delete this and click OK. Okay, now only we have the main elevation and the top plan view. So what we can do is we can click on the new viewport. We'll choose where we want to actually show our end caps, and I'll choose the view that I want to show. It will be end caps here. Okay, but I think we didn't make it for to be scalable. Let me edit it so that we can scale and align it. Okay, but still these end caps are represented vertically. I need them horizontally. So what we can do is in our model view, I will click on drawing views, show them. So our end caps are actually placed here in this view 9, view ID 9. So I will go in here in drawing views in properties, and I will just for the end caps turn this to the 90 degrees so that all of the end caps will be placed horizontally. So let me just redraw our drawing, maybe in the element. Okay, so with this configuration our end caps will be placed horizontally. It will list all of the end caps that are used in our drawing. Okay, so it is placed horizontally, and if we look at our main layout, okay, so we have the end caps at the bottom now. Now still we need to add the section and the solid also. So we'll go in our base, we'll check in here the new viewport. Okay, and I will choose maybe this much portion for this section. Okay, I will choose the section view 2, and again this will be aligned and the scale to fit. By choosing align, we can align it with this elevation so that it will be in one line. Okay, this is I think just a generation view that is giving some issues. Okay, if I just put a line here, you can see our both of our section drawing and the elevation is aligned. Okay, now we need the solid view. Similarly, we can click on our add viewport. I will add the solid. Maybe we can make it a little bit bigger. Okay, this one will much will be okay, and we select our view 8. Again this will be scale to fit. Okay, so we have our main solid view as well, but now this solid view is only in the top down top inform view. But if we need it to be asymmetric, we have the command for it, actually setting for it. We'll go in our standard admin, Oh, sorry. Till that opens up, we can look at maybe the reinforcement layout. Okay, it is taking a bit of load. Just bear with me for a second. Actually, it's a bit technical difficulty, just a bit. Till then, I think maybe I will just close it. Maybe I think I need to end this. Just for 2-3 minutes I am solving this technical difficulty. Maybe it will take me just few moments. Okay, for some reason there is a difficulty with our graphics card, I guess. Yeah. We are almost done actually with our seminar, so we'll just look at this quickly and we'll be done with this. I think the only portion remaining now is our shop drawing and its content, and we just saw some of the views and the viewports in there, and similarly we can adjust the viewport for the company standard as well, and whenever we make new drawings it will be applied automatically. Okay, and here let me try to open up one of the walls. I think I'm sorry, but we have to end this early because there is some issue with. Okay, maybe can we open up if we can just, yeah, okay. So earlier we saw when our many of the views that we draw, but apparently none of it is saved. But if we just redraw our drawing, it should be working fine actually, because all of those changes are actually applied in our database. So okay, so we do have our views. Everything is here except for the reinforcement. Maybe create the reinforcement view again. Okay, so as you saw, everything was saved in the database, so we didn't lose much any of our work that we did earlier, even though we faced a technical difficulty with graphics. So here we have our all of the listings. So if we can maybe, okay, the reinforcement we must have, yeah. So in reinforcement view we have all of our sections, reinforcement view available here of the bars that we saw and how to add them. Just like earlier we saw the views, similarly we can choose different views to be added in our templates from here. If I go into the template, okay, so we have covered most of our things in here. Again, we saw our views, then the viewports, and then again our contents. So reinforcement template have been covered, just like the sandwich walls. We can cover similarly for the solid walls and the insulation wall. And as you can saw, the automatic lifting was placed according to our definitions. So what we had was we used three configurations, one for the single lift and two if it was basically less than 2000 length of the wall, we use the single lift, and for greater than 4500 length of the wall we use 4 lifts. So the best thing about this program is that it does all of this automatically, but unfortunately I cannot show you more because thing is there is a technical difficulty with our graphics, but I think that is it. If you have any questions, you can add it in our chat box. Hopefully we can maybe solve them or answer them back. Otherwise we have the same seminar uploaded on our YouTube channel. You can upload your comments there also. And again we have this email address of our MD and our salesperson, and surely do visit our website and our contact numbers. Okay, then that's it for today. Thank you for joining.